Good morning, good afternoon, good evening to people around the world. This is your host of the Db2 Night Show, Martin Hubel, and today we have a Z show for you. Once again, we've got a very popular guest with us, Adrian Burke of the Db2 SWAT team from the IBM Silicon Valley Lab. How are you doing today, Adrian?
Hey, Martin. Pretty good. Thanks for having me on.
It's great to have you here. All right, with that in mind, let's carry on and get the housekeeping out of the way so we can get on to Adrian's presentation. And here's our social media page, as always. Follow us on Twitter using the hashtag Db2Night. Here's our famous disclaimer. Things are being recorded, and trademarks are represented as best we can, and it's all owned by DBI Software, who we're grateful to have as the founder of the Db2 Night Show. And here, oops, I knew I'd missed one thing. There it is. I've got last week's last week's show. I always miss something, don't I? It's a gift, really. Other people would correct everything, but not. You wouldn't know it was me if I didn't have a typo on my slides. That's was Ember Crook's show from last week. Shows coming up next month. We have on the LUW side, we've got George Backlars from the IBM Toronto lab talking about DB2 and Jupyter notebooks. We've had people talk on this before. Ember Crooks, for example, has done a great job on that. But it's also nice to hear the IBM side of it, so George will be speaking on that next month. And we also have our first show for 2020. Michael Rooken will be speaking on advanced log space management for DB2 LUW, and we're pleased to have Michael on the show. Next month, our last Z show for the year will be Tony Andrews of Themis, and that will be his best developer features presentation. Tony's a fantastic presenter, and I know you'll find that show great just before Christmas, so we look forward to those. As always, DBI has a demo that they do online. There's a demo video you can watch. You register. You also get a gift card from them. So if you want to learn more about tuning DB2 LUW, watch that video. And our winner from last week's show was Barry Lewis of AAA in Texas, and he gets a gift certificate that's been sent off to him. Once again, our sponsors are DBI and yours truly, Martin Hubel, and my little company here in just outside of Toronto, and 10 minutes from the lab up here in Toronto. Nice geographic location. And now we're into our studio audience polls. Bring these up, and I'll select the poll. And these are the standard things that we always ask you. So the poll is now open. What version of DB2Z are you running in production? People have voted quickly today. 92% of the audience voted in 20 seconds. That's pretty awesome. What we also see that's pretty awesome is we have DB2 version 11 and version 12, and nobody on DB2 version 10, so that's a good thing. We'll hide that and move on to the next question, which applies to 1/3 of our audience, which is if you're on version 12, which function level are you now on? Of course, we're going to have 66% of our audience say we're not on version 12. We're getting people to vote on that. That's coming through quickly again. Thanks for voting quickly. Allows us to get on with the show. At the 30-second mark, I'll close that off and share the results there. And of the people on DB212, 27% are still at the kind of the base level there, and people are on to function level 501 or 502. Just a few people there. Moving along, This is more content related now. Does your shop use profile tables? So we've give people a few more seconds on this. We're up around the 75% voted mark. We'll close that and give that result a share. 20% say yes, 40% say no, and 40% don't know. Hide that one. Next. Do you use high performance DBAs? Database access threads. Are they enabled in your environment? It's an interesting one, I'm sure, relating to today's topic. And with we've got enough people voted on that. We'll share 50-50 on those that know, and 27% of our audience does not know. And last question relating to topics today. Have you enabled sysplex workload balancing in the Java or .NET drivers in your environment? And this one people have voted on quickly. Thanks for that. And there's the result. It looks like about 1 or 2 people have implemented sysplex workload balancing. And an awful lot of people don't know. Okay, with that in mind, we'll close that, hide that. You should be seeing my screen again. So I'm going to move on, and we're now ready to turn it over to you, Adrian. All right, let me get to the right place where I click the little button in the right place, and you should now have a little pop-up telling you to here we are. Now you should be seeing a pop-up.
Okay.
When I see your screen, just need to maximize your PowerPoint, and away we go. And there we are, mines. Right screen. Good. As always,
yes, I even did the pre-check.
Question and answer tool. People have any comments, please use the tool, and I'll break in at the appropriate time to ask, freeze the questions appropriately.
Okay, thanks a lot, Martin.
Thank you.
Glad I checked my screen before we got started so I know which one's primary. So thanks, everybody. Good morning and afternoon, wherever you are. Thanks for joining this. We're going to talk about distributed best practices for today and tomorrow in DB2Z. I tried to make this topic somewhat generic because, as always, I like to include a variety of topics in the presentation to try to include everybody. So there's something for everybody, whether you're data sharing or not, and whether or not you're using all those features and functions I talked about in the previous slide in Martin's survey. So based on that survey, I'd say at least 30% of you should understand something on every slide, and 55% of you should be taking copious notes on planning for the future. So we'll see if that turns out to be true in the end. By all means, please interrupt if you like with questions and so on. 99% of these presentations I do are in front of an audience or at a customer site, and it's all based on customer experience as well as what we'd like to see you improve on. Those of us from the lab who want to see our customers succeed. So please, let me know as we go through if you've got any clarification or comments on it. So agenda, straight into high availability, which is kind of one of our key tenets on the mainframe. I want to make sure you're exploiting all the features there. If you've exploited it, then what might be some nuances you'd see in the workloads, talk about managing connections threads in this world of mobile workloads and REST services, and then how to monitor some of these things that may be sneaking in kind of the back door of DB2. And a final single slide on zips, because it's always a hot topic and I always seem to get questions about it. So jumping right into the weeds here, high availability or continuous availability, part of it is reliant on Z and LPARs and multiple LPARs, multiple DB2s, all the capabilities in there. But there's another little secret sauce we've got for DB2Z that's called sysplex workload balancing. And that is a piece of software in the driver that you simply turn on. We'll talk about that in a minute. But the workload balancing piece is a key function to be able to route around failures dynamically as well as manage workloads. So the little picture here on the bottom, if I've got a data sharing group, DB2A and B, and one of them goes down, or I lose the network, or comm server crashes, or the LPAR, whatever it is. With sysplex workload balancing enabled, what we do is we basically get an abstract layer of the physical connection of DB2, and the driver manages it. So this takes the control of the physical connection out of the application servers so that their connection pools become logical connections, and then the transport object in the driver with this functionality enabled is what manages the physical connection of DB2. So in this case, if anything happens to that DB2 connectivity-wise, that transport will be destroyed and we'll hook up that connection to a new transport and send it over to another DB2 if necessary, or that same DB2 if it was just an intermittent single socket that went down. And with that, if it's the first SQL of the transaction, we will seamlessly route that transaction to the other member of the DB2 without the application even knowing. We will send a positive SQL statement back if it's monitoring for it, but otherwise he knows none the wiser. So we'll redistribute connections, move the transaction over if we can, and then keep going, business as usual. Now, if that connection's lost or drops and you're in the middle of an update, delete, insert, so on, we obviously can't just reroute the transaction because part of it may have been completed on the other member, but we will redrive a connection, flow all the special registers and variables, and then we'll give a negative SQL back so that the application knows to redrive. So this is, I said, all behind the scenes with this parameter enabled. And even if you're not data sharing, if you have problems with any kind of internet connectivity at the LPAR level, or a gateway or firewall in front of it, this behavior can help mask any of those connection issues, and you can eliminate those stale connection exceptions you'll get in the pool. So pretty big deal. So the recommendation, obviously from our team, would be to enable sysplex workload balancing to true. So that's the parameter right there. And not only does it do what I talked about in the previous slide with seamless connection reroute, but the other part is intelligent workload distribution. And this is at the transaction level. So if your other aspect of high availability is having, say, a sysplex distributor in your ZOS environment, which is just an address space that routes connections accordingly, it's managing only at the connection level. So once that connection is established, it can't do anything else. With sysplex WLB in the driver, we can actually distribute these at the transaction or commit scope, which is a pretty big deal. So the intelligence in the driver basically, it connects to DB2, DB2 queries WLM, WLM tells the driver what, a list of members and their relative weights to say which member we should run the most transactions to. So that weight that we get back from that is dependent on three key factors: displaceable CPU and zip, the enclave service class attainment based on its WLM goal for the distributed workload coming in, and then finally DB2 health, which is primarily virtual storage constraint, which should be kind of a no-op at this point in DB2 11 and 12, and also if you encroach upon your zparm condbat, and then some other factors I'll talk about in the next slide. So if you choose to enable it, so there's three factors here. How am I going to ensure that those factors are positively affecting where workload is routed in my data sharing group, for instance? Now, if you're not data sharing, obviously, the weight will come back with a single member, and that's where all the work will route. But again, you can get that the key benefit there would be to shield your applications from stale connections. So in data sharing, we've got this. We're looking at displaceable capacity of the LPARs where the DB2 servers live. So the key ingredient here, recommendation, is a symmetric configuration. And we know that's not attainable in all environments because you've got things like penalty boxes, specific LPAR where specific workloads run based on software pricing, unfortunately. But ideally, if it is symmetric, then we should get an even workload distribution across those LPARs. Historically, we've seen that the spare zip capacity seems to help shift workload around, but based on our descriptions in the code, this zips and CP should be weighted pretty equally. So if there's displaceable capacity, that's where that work's going to go. The next big one is the performance index, meaning how it attained its goal based on WLM of the enclaves in the DRDA workload coming in. So if they're delayed on one LPAR, so it either missed their performance index or WLM sees the queue growing, then he may shove this workload either to another member of the DB2 data sharing group. We've had customers who've seen this and have affectionately named it sloshing. But if your goal is not accurate or realistic and attainable, meaning the goal in the WLM policy, then if this EDF workload either never makes its goal or makes its goal regardless because the goal is too loose, then you'll get inconsistent behavior, right? If it never makes its goal, there's no telling where we route the work. It'll probably just go in order of the DB2 subsystems. And if it's too loose, the fear there is that WLM is going to react too slowly. So if you do have a CPU constraint, some other bottleneck, threads pile up, elapsed times increase, then WLM will react too slowly and your applications will suffer. You may get timeouts or something else in there. So you really do want to monitor the goal of how that DRDA workload is achieving its WLM goal. And the RMF72 subtype 3 records are a key piece there, and the workload activity report will show you that. We've done other presentations around where I've talked about the RMF spreadsheet reporter, and it's a really simple, kind of sleek way to monitor whether or not that workload's meeting its goal. And finally, the third factor is the DB2 system health itself. So DB2 is going to report to WLM its health. I've got a display thread type system example right here. 507 message, and you see the health is circled at 100. Generally speaking, DB2 should always be at 100. If they're not, you're going to see the workload shift pretty violently to route to another member to ensure it's meeting its SLAs. And the biggest one that gets affected there is ConDBAT. So that's your ZPARM that controls the number of total active and inactive connections. And if you get over 80% of that ZPARM, we put a message out in the master job log, but we'll also drop the health by 25%. And that's pretty much going to mean we're going to route almost no workload to that DB2. Because if the other members are all at 100, it drops it pretty far down the list. Of course, if you encroach upon 31-bit storage, which today is either a storage leak or you've got, well over 100,000 data sets open, and you've got a pretty small region size, then in that case, you can end up with these constraints, and we'll put a DSN VMON message out for that to let you know to look out. And the last one is whether or not we might boost some workload. So internally in DB2, if there's a workload holding an important lock or latch, we can request that the dispatcher boost the dispatching priority of that unit of work and try to get him up and out of our way. So if that number is greater than 0, you're probably pretty CPU constrained, and there's other larger issues to take note of. Okay, so somewhat hot off the press, at least in the last 6 months or so, we've finally come out and pretty much stabilized a new sysplex workload balancing algorithm. So if you've already enabled sysplex WLB, when you get to this level of the driver that I'll show you in a minute, this will come on automatically. So there's not a parameter to control this new algorithm because we are pretty certain it's going to help everybody. But we've worked with customers around the world for the last 2 years or so trying to get this functionality enabled because we saw a gap in the market for customers that were using the previous version. So what are the issues we've seen in the field? So my customer experience, we've got 2 LPARs, and one LPAR has 1 member, the other LPAR has 2. So when WLM sees this, he takes the health of that LPAR and divides it by the number of servers on that LPAR. Why would you do that? Well, the capacity is obviously based on the LPAR, meaning how many zips and general purpose engines it has. So he's going to route work on the LPAR based on what percentage of the total workload, that LPAR should take. So my example here, DB2 is reporting a weight, or pardon me, WLM's reporting back a weight for DB2A of 10. The other 2 members, B and C, have respective weights of 6 and 6. So that LPAR, that means SYS2 LPAR, should be taking about 20% more workload than the SYS1 LPAR. The 6 and 6 is 12, so should be taking 20% more workload than that other LPAR. But in my example, the customer who ran 1,000 transactions, what they saw was the first LPAR and the first DB2 that came back on this list from WLM got 86% of the workload, and the other one got 14. So it was actually inverted as far as the percentage of workload to that LPAR. So we went back to our friends in driver development to take this test case back to them. What they discovered in their test case that they'd run is that in a lab with 1 member rated 50% and the other 2 members equaling 25%, which is kind of the equivalent of my customer test, if they ran short transactions consecutively, meaning one after the other, what would happen was they'd all end up on the first member in the list. So that's the healthiest member. You do want more workload going there. But in this case, all the work went there. And we discovered it was because the algorithm was based on not just the weight to the DB2, but the load on the system. So it needed more than 1 transport in flight at any given moment in time for it to distribute workload around the rest of the members. So if we had 1 long tran and a bunch of shorts, the long tran would land on the first member, and as long as it kept going, we would start running all the workload, the short trans, on the second member, and so on. So it's just with a mix of all these that we'd end up with a good example, which is on the far right, which is what, in development, they'd seen in their test case. So the problem was, like I said, the transactions usually ran on the first member, and if there was no concurrent load on the system, they just stay running there. So a pretty simple fix to this is 11.1.1 mod 4 fix pack 4 of DB2 Connect, and that's driver level 42514. Pretty simple fix. At the next time they do a get transport to get a connection, he's going to remember the last member of the transaction ran on. So if it was DB2A last time, he's going to run on DB2B this time. So it's going to be effectively a round robin workload until there's concurrent work going on, until there's an actual load on the system. Then it'll start portioning, trying to get 50% of the trans here and 25 over there. So what we saw in the test cases after this pretty simple change, we got the correct distribution across the board. And in my customer example on the bottom left, after they implemented this new algorithm, you see the weights on the left chart. So member DB2A was weighted 84%, and the other 2 members were 16. In this new algorithm, the accounting reports and the number of transactions run were within 2% of ideal, meaning within 2% of how WLM had weighted those servers. So pretty much a slam dunk as far as we were concerned, compared to the previous example where 84% ran on the lower weighted member. So a good win, and hoping other customers will start adopting this as they go through that maintenance, pick it up, and see some similar successes. So of course, anybody who's testing or looking at this, by all means, send me a note and let me know some feedback on it. Okay, that was the sysplex distribution and availability part. I'm going to jump into kind of the defensive measures now of system profiling. So I have to admit, I was in training for emergency management for the state of Texas all week, thanks to my involvement in the Air National Guard. So I've just been talking about or hearing about floods and fires and tornadoes for the last 4 days. So in this example, we're kind of harkening back to, I don't know, a flood of DRDA connections and threads. So we're talking about how to defensively posture yourself so that Db2 doesn't become a victim of this stuff. So system profiling. So since starting version 8, at least of Db2, where it allowed you to manipulate some Z-parms based on setting up a profile in Db2. We used to do it to manage things like tricking the optimizer into thinking it was running on a bigger machine or a faster machine or one with more memory. And Terry Purcell has talked about some of this before, about how to mimic access paths in production and test. And we've continued to expand this capability in Db2. And in this example today, I'm talking about monitor profiles that help you manage connections, number of threads, and the idle thread timeout. Now, along with that, we also have the ability in these monitor profiles to specify special registers. So you could set the degree of parallelism that's available to the applications. You can also set current package path, meaning like which collection or which package that inbound transaction is going to run on, as well as Apple Compat, which is certainly a key ingredient version 12 moving forward, and things like whether or not it goes to the IDAA or query accelerator. So in the catalog, these profile tables, there's 4 of them. There's the profile table, which is basically who you're profiling against, who you're filtering on to manage. The attributes is what you're monitoring, threads, connections, idle thread, timeout, and the special registers. And then you got a history table associated with each one. And the history just basically tells you whether it was accepted or rejected, and then the reasons why. So when you do this, these are just inserts into these tables in Db2 that you do, and you go back and check the table in the history to see if what you put in was accepted by Db2. So once you've got these things set up, and I'll show you some examples in just a second. Once they're defined in there, you just do a start for the profile, and it starts all the profiles that are enabled to come up. And the DBM1 address space keeps track of these, and we started it in version 12, retroed it back to 11. There's this Z-parm that allows these profiles to auto start, meaning you don't have to go in and do it after Db2 comes up each time or have automation. We'll start it on our own. So monitor connections means you're going to limit or monitor, for instance, ConDbat, which is your Z-parm for Mac's active or inactive connections. And this is all in the profile attributes table. The number of remote connections is obviously you're talking about TCP/IP here and DRDA. So these profiles can either be a monitor or an exception. Monitor means we just put a message out in the master address space. If it's an exception, then Db2 will automatically take action. It'll put you a message out, but then it's either going to say reject a connection, suspend or queue a DBAT, or time out a thread. So an example here, if I set monitor connections to an exception and I set it to 100, then the 101st connection from whatever that I've profiled on would be rejected. So it's kind of a denial of service. And you can filter that on IP address or domain. Now, if I'm concerned about threads in my system, about different applications coming in and gobbling them up, I can set this parm, which is related to max DBAT. It's a mini version, so it has to be smaller, right? It's a subset. So it's total number of active threads coming in. They're being used by this application or auth ID or client user, client application name, and so on. So the threads has different behavior depending on what you filter on. So for instance, if I'm doing it on auth ID and I set the number of threads to 100 for a limit, then that means there's going to be 100 that are active. And based on the current behavior, if you have more requests coming in from that same entity you've limited, you'll get 100 that are suspended. They're kind of queued in Db2 waiting for one of these other 100 to become free. And then the 201st one would be rejected if it was an exception on auth ID. Now, if you manage it based on IP address or domain, if that's how you're filtering, which is going to be in the location column, then it behaves much like a max DBAT, where you get 100 in there that are active, and then the other requests from that same IP address or domain will queue all the way up to con DBAT. So you're really just limiting the active threads that are in there. You know, if it's a normal situation, they commit, that thread goes back to the pool, he can be picked up by somebody else you're profiling or any other transaction. And the last one here is the monitor idle threads. So this is setting idle thread timeout, or IDTHTOIN. You're setting that ZPARM at a more granular level. Now, when you set this, whether you're doing a warning or exception, you need to realize that if anything qualifies, it no longer abides by the ZPARM. So we have this in the documentation, but I'm just going to make another note here. If you're playing around with this, because you might use it to check to see, you know, what the average time that these threads really remain idle, because your idle thread timeout is probably at 30 minutes, I see, is a pretty common setting. Well, maybe they're only really idle for 15, but you had to set the number so high nobody would get clipped, right? So in this was setting up a warning. I'd set up a warning at, say, 15 minutes to see if anybody is really idle longer than that, and then I'd set an exception at whatever I had the ZPARM at, which was, say, 30 minutes, because anything that qualifies for a profile is immune to the ZPARM. So that's kind of the point there. So how do I monitor these things? Well, you're getting the messages out in the master address space, and I'll show you those examples in a second. And we're also populating statistics class 4. It's ifkid 402 specifically, but that should already be active. So in stats class 4, you're going to get these, well, the numbers of times that these profiles have been hit. So the other thing we can set here, talked about threads, connections, idle thread, is special register. And this one's becoming more and more popular with my customers, and that's why I wanted to include an example here. You can use it to manipulate the current package path. So this could be done at the driver level, right, or in the data source for these inbound applications. But a lot of times, as we know, remote applications don't know what's best for them. So in this case, you can use a profile to guide inbound DRDA workload to the correct collection or correct package for them to run on. So for instance, you know, in a 24/7 environment, it's about impossible to rebind the null ID collection. So that includes all your JCC packages for dynamic SQL, like the sysln, syslh 1 through 400 packages. So customers have a hard time rebinding those, and with the use of a profile, they can set the special register for the current package path and point it to a different collection. This allows you to get, you know, break in for rebinds for Db2 upgrades, as well as to use, you know, special performance enhancing bind options like keep dynamic or release deallocate for high performance DBATs or degree of parallelism. So you might use a profile to toggle between different collections for migration. So you're trying to shut inbound connections off to one of these collections and push it to a new one, or you segregate where some well-behaved applications get to use these high-performance packages and the rest of the folks just use the generics. Now that's also going to play a key role in your version 12 migration moving forward with continuous delivery, because if you want to take advantage of the new functionality and the new function levels, the packages these transactions touch have to be bound with the correct level of Apple Compat. So you're going to have to end up rebinding some of these JCC packages with higher levels of Apple Compat so that the applications can use new features. So as a recommendation going forward, you're going to have at least 2 null ID collections. I'd recommend having a null ID that is the same that it's always been, and another collection for applications that want to use new functions. So you might have a collection for each function level, or you might just have one that's related to the highest function level available, and then one that's null ID, which is basically the equivalent of, say, function level 500 in version 12. But that way, the applications that are continuing to run, not changing, don't know any better, So that's what we're really trying to provide you as a safety mechanism here. So going along with this, and I'm going to give you some examples, the insert statements and so on for profiles in just a second. I just want to continue this thought about setting the the special register for current package path. So in version 12, as I mentioned, if you're going to execute new functionality, you're going to have the packages bound with the right level of Apple Compat. So we've added an additional property in version 12 called client Apple Compat. So we've had some customers in version 12 that ran through really quickly and wanted to get on to function level 501. And when they did this, they kind of shot themselves in the foot because they were overly aggressive on the Db2Z side and the clients were back level. So if I have a null ID collection, so your dynamic JCC packages, bound with an Apple Compat less than 501, or a null ID with Apple Compat greater than 500 and the client Apple Compat isn't set, I can end up with basically the connection being rejected. So if the Apple Compat is too high and my driver level is back level, connection fails. If my Apple Compat is bound low and the client tries to use a higher function level, that's going to fail also. So we had kind of a quandary there. So we put out an APAR 8482 that allows the setting of client Apple Compat to be optional, but it only applies to version Db2 Connect 11.1 fixed pack 1. So if you're on Db2 Connect version 10, you can't set client Apple Compat because it doesn't exist, and hence you can't connect to any of those packages bound at 501 or up. So I'll make that pretty clear here. Even with this parameter to make Apple Compat optional, because customers have trouble getting the applications to set this property or to set it in the driver. Even if you have that on, your driver level has to be 11.1 fixed pack 1. So that's why you're going to need at least two collections, one with a null ID, which is bound at function level 500 or below. And that means those apps never worry about this client Apple Compat, and they're not going to use any of the new features in function level 501 or up. So the next bullet, the packages null ID are going to have to be bound with an Apple Compat at some point, right? Some point in the future we'll deprecate some older ones, you're going to have to bump them up. So having this strategy in play of how to manage which applications use which collection are going to be pretty key. We've had, customers talk about, null ID 501, 502, 503, so those applications, and they know which ones to point to, and they can set it by the profile or force the applications to set that in the driver. Here's an example of them setting it for the collection ID. So this includes all the variables, meaning all the columns in the profile tables. But if I set the auth ID to wildcard, meaning everything coming in, and down below I set the special register current package path to null ID 501, that means everybody coming in is now going to point to my 501 collection, which should be exploiting, right, version 12 function level 501. So obviously, if this is the down level guys, you're going to point everybody to the null ID, and then those applications or through a profile I can set up to be up level to utilize these new feature functions, the new packages. Okay, here's an example of some of the profile monitoring. So here's the two tables, profile table and attributes, and just some examples of what I can do. So if I want a wildcard on auth ID, I've got wasprod, like WebSphere production for my app servers. The group or member, like DPG1 here, just says what it's starting on. So you're going to have to create these profiles in each of the DB2 members. There's not one that is data sharing group in scope, right? But this just basically helps you track it for the group or member level where you're wanting it to run at. But each one, because it's in the catalog, right, the the group can all see it. So which member do you want this profile to start on? Just only this member. Okay, but you still have to use the start profile command, right, or set the zparm on each member for these to run on it. So with that example, he's got monitor threads, there's 100, and it's an exception. So that means we'll have 100 active threads, we'll have another 100 that are suspended waiting to run, and then the 201st one, because of an exception, would actually be canceled. So that thread would fail, and then the application would have to redrive it. Profile number 2 here, a couple examples, the JCC03. So this is the product ID for the JDBC 3.0 drivers coming in. Well, realize those have been stabilized for actually a couple years now. So there's no new features or functions going in to the 3.0 drivers. There's break fixes, but no new functions. You got to get to 4.0 to take advantage of new things like the sysplex workload balancing. Another one for product ID that's pretty new, HTS is the high-level qualifier for any RESTful services coming in. So any native REST connections to Db2 are going to start with this. So I could limit, you know, how long the idle thread timeout is for these guys specifically to whatever I want, higher or lower than the zparm. And then finally, as an example of location, anything coming in from SVL and IBM, I'm only going to allow 100 connections from each instance of this guy. There's other wildcard options, and we've got examples on the web for that as well. This is just an example verbally of what I did on the previous slide. One thing to point out here, there's different diag levels. So diag level, you know, nothing or 2 or 3, you get more and more information. If you're trying to troubleshoot to find out who the culprits are, diag level 3 is what you're really going to need. Now, if I have a diag level 3 here set for connections, for instance, every time there's more than 100, I'm going to get a message and an alert out. And we've limited the messages to come out at most every 5 minutes, and it'll tell you how many times in the last 5 minutes that profile was triggered in the DSNT7 messages. But we've had customers, you know, flooded the console with these because they've got basically a denial of service attack going on in their environment. So with IFKID 406 right here, you're able to start this trace and use a diag level 2 or less so that we don't push a message out for each occurrence. But what we do is write this IFI record for it. So you'd start this trace to get all the detailed information to see the IP address and everything of what's coming in through here. Now the 5-minute interval for these messages is for diag level 2 and below. So it'll just tell you which profile was hit, more or less. If you want an example for every person who's, or you know, every thread, every connection that's broken your profile, right, that's gone above it, then you need diag level 3, and we're going to kick a message out every single time it occurs. So I'd probably recommend looking at the IFKID 406 so that you get all the detail you need to troubleshoot, but not flood your job log. And on the, you know, the Knowledge Center, as well as to give you a link in the back where I wrote a blog about profiles, you can look at all the DSNT messages and all the associated error messages because they're unique for each combination of profile. So it is pretty granular about what you can understand about what's coming out. Okay, I'll draw a breath. Are we still doing okay, Martin? Any questions come in?
Sorry, I had to find my new mute button. No questions, so you're doing great.
Okay, I'm warning you in these things, if there's no questions, then I start accelerating through these slides. So I'm going to try to make sure.
We'll get off
mental
on time. No, just kidding. That's great.
We'll stay on schedule.
Stay on track, yeah.
So we talked about profiles now. We've talked about high availability. Now, what are the scenarios we've seen in customer environments? So a big one today is that applications, or application servers, I should say, pick up a connection and never let it go. Now you might say, well, keeping a connection is good. Long-lived connections are good because it avoids us having to authenticate. It avoids overhead of like the SSL handshake and so on. But some of these aren't intentional. It's just poor coding practices, like not using connection pooling at all, or using validation queries where the pool is constantly asking whether or not DB2 is still there, right? Or it's applications that are not high in volume and don't need concurrency, but use a different connection each time it comes in, and then those connections just lay around forever because they've disabled the connection timeouts in the app server. Because remember, in the DB2Z world, I can't time out a connection, and I can't close a connection unless there's an active thread associated with it. So if I go into inactive threads in the display and I start canceling those, all I'm doing is killing off control blocks in DB2. The physical connection's still there, and those connections all count towards ConDbat. So example, one of my customers who's in finance, they're going along, this started Monday on the online day, they've already got a whole bunch of this gray, which is inactive connections. So this is just kind of baggage we're carrying along. If a thread came in on that same connection and used it, then great, it's useful. But if application A creates this connection and then goes away, application B on a different app server, for instance, can't come in and use that same connection because the beginning and end point of that socket are controlled by application A. So in this example, we've got this overhead of inactive connections that grows and grows and grows, and eventually, right about starting at around 1 o'clock in the afternoon, they start getting connection failures, meaning other applications can't connect to DB2 because somebody is using all these connections here. What this, to make the story short, the DBA went out, looked up the IP addresses of these connections, found it was all from one app, called the app owner, and he said, oh, I just got back from lunch, let me close my spreadsheet, and then magically, right, at about 1450, all 800 connections that were unused went away, and everything started processing normally. So this ended up being an OLADB connection that had over 800 connections from this one workbook. So it's very easy, right, to take these over if you're not paying attention. So, the next day, this customer went out and put a profile in to limit the number of connections from this IP and this, this location where it was coming from. Like I said, these are all real stories from the field. We can't make it up. So what are we going to do to address this? Well, if you enable sysplex WLB in the driver, behind the scenes there's a timeout. So if the physical connection isn't used for more than 10 seconds, we'll kill it. We'll get rid of that, that physical connection, and we'll get rid of that transport. So we're doing the cleanup for you, because remember, it's at the driver level. In DB2, I can't close that socket, no matter what command I put in. So if you've enabled it, you want to set ConDbat pretty high. I'm going to set it up to basically the total of all the connections that can come in, which is based on the max connections from your app servers. Add a little fudge factor and set ConDbat to, say, 1.25 times all the inbound connections on each member. And if WLB is enabled, then it's going to keep the number of concurrent connections down to, based on the workload and concurrent activity. So it'll be a manageable. If you rely on the application servers to set their max connections, whatever, and they don't have a connection timeout or a reap time for inactive connections, then you end up with this huge connection growth, right, which continues over time, and you'll eventually encroach on ConDbat. You also want to make sure you disable the validation queries in the app server. This is really popular in open source stuff like Apache Tomcat, where they're used to working with substandard databases that don't guarantee continuous availability. So they have to continuously ping the database to see if it's still there, right? To make sure it hasn't crashed or gone away for the day. We don't need that, so disable it if you're connecting to DB2Z. You can also consider the use of dynamic location aliases to allow you to, if you get the applications connecting to that alias, and these are the ones that, you don't really trust, you're always able to shut down that alias without affecting the rest of the DDF traffic, kind of at your will. So if these guys get out of control, you can manage the connections coming in from that application. And of course, as we mentioned, setting up a profile is a pretty good idea too. So I'd recommend pretty much every customer have a generic wildcard, and this 0.0.0.0 or wildcard or asterisk means I'm only going to allow X number of connections for any unique IP address. So maybe just say 100 as a warning to start monitoring and see how many unique IP addresses actually hold over 100 connections each. So you're just learning into it. You can also do, display location detail, summarize those, look at the inactive connections to see what IP those threads used to be associated with to kind of get an idea. But this generic profile really helps with, denial of service attack. I've got a customer who's also in banking who noticed that once a month, they get thousands of bunk requests from an IP address that trace back to Russia. So it was interesting that they didn't have any customers there because they're an American organization. So setting up a profile really helped them avoid the overhead of the authorization failing basically in Db2. So again, if you want to see who is actually doing this, where the IP addresses are that are popping this profile, because it's wildcarded, you won't know which one until you look at the trace. You need DIG level 3 or the IFPID 406 trace to see who it is. Next one, got applications that gobble up threads. So this is usually due to a lack of an effective commit scope. Namely, we see applications that certainly aren't production or transaction oriented, but owned by an individual user or something where there's manual or human intervention, and they choose to not commit because that would mean they have to come in and re-sign on again. So that would be a poor practice. Also an audit exposure. But even if they do commit, you've got things like if they're bound with keep dynamic, global temp tables, or even, as I'll talk about in a minute, overuse of release deallocate for high performance DVATs where they end up taking up all these threads. And when you get a rush of connection requests, because we know DRDA workload is pretty spiky at times, Black Friday, whatever, at market open, rush of connections coming in. Well, a lot of customers forget that each inbound connection request has to go through authentication to see if we're going to allow them in. And we do that authentication on a DBAT. So if you see a flood of connection requests come in, each of those is going to need a DBAT to authenticate, to either reject them or allow them in. And that authentication isn't part of the enclave because we need to know who they are before we put them on an enclave, and hence they're not zip eligible. So we've seen customers a lot of times at certain points of the day, a rush of connections equals hit and max DBAT equals CPU burn. So if we can manage these connection requests on the front end, you can help yourself a lot. Now, release deallocate, the high performance DBATs came out in version 10. We've seen 10, 15% CPU savings on up with the right applications using it. So you bind the package release deallocate, use a modify DDF package rel command to enable it. So you turn that on and off with a command. So we've got a safety mechanism in there. But a lot of customers have turned this on across the board. So if you rebind the null ID collection release deallocate, every inbound dynamic SQL, including every store procedure call, will be a high performance DBAT and will get a thread and keep a thread. What's this look like? We're using high performance DBATs, and I've got a little animation here. So no high performance DBATs, how it normally works, you get a request comes in, it uses a thread, at commit, the connection goes away. Now, if I enable high performance DBATs, when these connections come in, they're going to grab onto a thread and they're going to hold it for up to the pool and act timeout value. So up to the default of 120 seconds, you may have a thread with nothing running on it. So your number of concurrent threads is going to go up astronomically. The example, if you've got 100 transactions with a lapse time of 10 milliseconds, one thread could handle 100 of those a second, right? Whereas if you move to high performance DBATs, now you need 100 threads to manage 100 trans within that second. So we've had customers ask, is it 2x, 3x the number of threads? How big should I make max DBAT? You're going to have to test it, unfortunately. So the timeouts, again, idle thread is for a thread that has issued SQL and, for instance, hasn't committed. Pool and act is normally how long these threads live without being associated with a connection or an application. They're just in a pool waiting to be reused. But with hyperf DBATs, this pool and act is going to say how long a hyperf DBAT can remain idle without doing anything before we blow it away. So the best practice for high performance DBATs is to make sure that this transaction issues at least 100 commits or 100 transactions before it goes away and severs this connection. So if you're using connection pooling and everything else, probably not a big deal. But if you're looking at your accounting reports, you can see number of commits, for instance, versus CONVI. CONVI is the number of conversations deallocated that are coming in from the remote location. So if this ratio of commits times CONVI is less than 200, it's not ideal. If it's greater than 200, like this guy, 2,000 commits, never disassociated a connection, that's great. Because behind the scenes, we only use a high performance DBAT 200 times before we recycle it. But if you close a connection after 1 or 2 transactions, then we blow away that high performance DBAT and close the connection, and you can create an overhead in the dist address space by doing these constant create and destroy threads. Now in the statistics report, I can see, based on current active DBATs bind deallocate, how many threads are in the system that are only active because I bound them release deallocate. That means they're not actually doing work. An example here is the green, it's that field in statistics. These threads are active only because they're bound high performance, not because they're doing work. So in this customer, this orangey area down here, there's about 200 for active concurrent threads. Green are about 1,000. So when they turned off high performance DBATs temporarily for this application, they went down from 1,200 DBATs to 300. So it makes a pretty big difference in there. I said you're getting performance benefit, most likely, from those guys that are using it, but you've got to realize your infrastructure and the number of threads that are in there are going to be a lot higher. And if all these threads lit up at the same time, right, that's going to be a lot of CPU, and can you handle that? Okay, so continuing on talking about managing thread usage. Again, set up a profile to help monitor them. You can look in your stats for the high watermarks of active and disconnected DBATs. That's one field, and then see what your normal is. Then set up a profile with a warning, or you can automate the display command and see how many threads you normally have in your system. Then you set up a profile based on more specifics, like auth ID or client application name or something. So you see the threads that are associated with these profiles. And that's really a measure of concurrency, because I'm not sure any other way to determine how many concurrent threads for some specific application exist. You really have to get a profile to understand true concurrency in your environment. You can set up an idle thread timeout to a more manageable number. You know, right now it might be 30 minutes, and that was 10 years old. You can start playing with a warning threshold in the monitor idle threads to see where the real number is. Maybe they're only idle for 5 minutes. So you can lower that number down or apply it just to the ill-behaved applications, and then set idle thread down to 2 minutes, which would be normal. So you just got the exception for the ones that really need a 5-minute timeout. And of course, for high performance DBATs, test, go through the litmus test I talked about in the previous slide, and only allow well-behaved applications to use the release deallocate packages. And here's an example for the profile. Once again, to set certain applications to use certain collections so that then they are the only ones allowed to use a high performance DBAT. Okay, that was managing. I'm going to talk about monitoring for just a couple minutes. How do you differentiate remote applications coming in? Well, if it was a local attach, there's a myriad of ways, right? As soon as we move to the kind of a DRDA architecture and inbound things, especially today in a cloud environment, you have no idea who's on the other end of that, right? Generic auth IDs, use, you know, some Amazon Web Service or something else coming in calling you. You really don't know who it is. So you got to figure out how to inject identifiers into that connection string or the thread so that you can identify them. Why? Because you need to know their service class or how to properly identify them in WLM. If you're going to use chargeback, you've got to know who it is. to be able to tune SQL, dynamic SQL, other than run stats, you know, that's all you can do if everybody has the same auth ID. And then, of course, root cause analysis. So example today, a generic Java application coming in, the correlation ID is Db2 JCC, and that goes into the application name or transaction name. And then even the accounting record, right, is an IP address and the version of the driver. So not too useful. And all this information flows all the way back to display commands, you know, in the accounting records, and even SDSF enclave displays. So you really can't identify what's going on. So enter client accounting information, which came back in version 8. So I've got a little chart here of the different client accounting fields you can populate, whether it's Java or .NET, what the keyword's called in each of those, whether or not it can be used for WLM classification, if you can use a monitor profile to limit it, and the special register and size and macro. So this example, I think application name is pretty good. It's a good granularity, where I can get all the information back in accounting and display, and I can use it in WLM as well as a profile. Also, a good thing, it's a special register, so the application can test with it, pull back their own special register value, and make sure that it's populating correctly. So the example here, for .NET, you've got to set another parameter to allow you to populate these fields. For Java, it's enabled already. So the most granular way would be to have the applications code to the API, say set client info. It's a standard Java API and method. And they're going to say application name. And then if it's .NET, client application info and the CLI. And what I can do there is populate the application name. I can override the client accounting information itself. And then, of course, because I've got this, I'm able to set up a WLM policy that accurately identifies my application and can accurately categorize him. And here's my WLM service class. Now, if you can't get them to do anything in the application level, you can do it at the application server level. So WebSphere has a resource reference, or just in the data source property, you can say, you know, the admin goes in and modifies that data source and says, these are those fields, you know, client accounting name, application name, so on, sets those, and everybody that uses that data source picks up those properties. But if you've got a whole bunch of applications, different runs running through the same data source, you're going to lose granularity there. If you're lucky enough to have applications, many applications that all come through the same app server, but it's homogeneous, right, in nature, so it's really just one app per app server, then you can get away with just changing the property in the JCC driver itself, or the INI file if you want for .NET. So if it's very homogeneous, you might be as simple as this. If you got multiple data sources, one app per data source, use number 2, or you might have to get them to actually code it, right? Code to the API, which is the most accurate, but then again, it involves the application taking some ownership. Now, these fields also apply to REST services. So if you're using the native REST in DB2, the correlation ID will always come through and say DB2 REST. And then the application name here is going to come through with the name of the REST service you're invoking, which also maps back to the name of the package in DB2. So we're doing that all for you. But if there's something else you want to manage, like to understand who's making the call, the one field you can manipulate is user agent. So you can change this in the header field of the REST call. And if you say user agent equals AGB, for instance, then what's going to change is the workstation name. Normally it's going to be whether Internet Explorer or Firefox or whatever web server or browser you're using. Instead of that, I can override it and put this field. So that's really the only one you're in charge of on the customer end. Rounding it out, so this is the only slide I'll talk about pricing, and it's not even going to be actual numbers. But you know, a couple of years ago, they came out with a mobile pricing option, and this is pretty powerful. You know, today there's things like container-based pricing and other things, but you end up managing the resources they consume. So you put them in a container, in a box, so to speak, and that's how much resources they get. Now, if you've already got distributed workload coming in that is mobile in nature, there's a way where you can just get a discount because it's mobile, and all you're going to do is manipulate the WLM policy for the reporting attribute to say mobile. So a real, instantaneous change in the WLM policy to put in this attribute. And if you can prove that it's a mobile workload, then DB2 and the RMF data pick up all the information they need. Even in the WLM activity reports will tell you the percentage of mobile transactions on zip and general purpose, and you can just feed that back to your IBM friends and they can get you a discount on the software. So this is contractual, right, to set up mobile pricing. But once you've got the paperwork behind you, enabling it technically is very simple and has no impact on the environment or performance. And my last slide in here is a quick warning. We've seen a lot of issues with zip capacity lately, where customers are running zips, not even like general purpose, but just like extra for fun processors, when really you've got mission critical workload in there running, not just your transactions, but system agents in DB2 that have low latency demands where you have to have the zip capacity. There's special things if it's special behaviors of zip eligible work. If you let them fall down to a discretionary service class, like if you don't categorize them and they fall into sysother, if that workload's zip eligible and it's running discretionary, there's no needs help algorithm, meaning no matter how zip starved that tran is, he will never fall back to a general purpose engine. So looking at RMF, one of the ways to tell whether you're short on capacity is looking for IIP-CP CPU in the WLM activity. That shows zip eligible work that ran on a GP. That is because the needs help algorithm was invoked and the zip went, hey, I need more processing power, and we pushed that work to a general purpose engine and it finally made it through. The idea is not to kill, right, the SLA or miss its goal. But this needs help doesn't apply for discretionary workload. It also won't apply if you set honor priority to no, which you can do in the service class now in WLM starting in, I believe, ZOS 2.1 with maintenance and up. So you can set honor priority, meaning whether or not I allow you to fall back to a general purpose engine. Honor priority says no, you'll wait for a zip. Honor priority yes says, if we're in trouble, I'll go ask for help. So this, if it's discretionary, it's pretty much already honor priority no, we won't fall back. And that's dangerous because we don't have the needs help. And the other thing that's not on the zip is block the workload support, which is an enhancement from ZOS that helps us free up locks and latches if there's a process, a zip starved agent out there that's holding something important, lock or latch. There's no block workload support on a zip. It's only on the GCP. So I said, not to worry everyone, but we've seen several instances lately where their zip capacity starved and it's affecting things like the agents in DB2, which I'll remind you are prefetch, deferred write, group buffer pool, cast out, and log write and prefetch. So if you starve the ability for DB2 to write log records, right, you're going to affect a whole bunch of things in the environment. Okay, didn't want to end on a down note, so here's some great references to go out and look at. This news from the lab is a really key way or avenue for us to get you in touch with the developers, for them to write entries about new code coming out and keep up with it, since we don't have big release or migration workshops kind of now with continuous delivery. This is where we talk about some of the key features, and the one I wrote is about profile tables if you want to learn some more. So other things to look at in there for reference. And if you ever want to kind of hang out with a SWAT team in SVL or in a lab in England at the Hersley lab, shoot me an email. We do a week-long DB2 performance class where you can hang out with us and we'll talk about good stories and bad stories we've seen around the world. But with that, Martin, do we have any questions?
The queue has been clear all day. I think you've just done such a fantastic job that you've answered the questions before they formulated in people's mind.
I've baffled them with BS or left them in the dirt. I'm not sure. But certainly open. If you have any questions, my email's on here. I'll distribute the slide deck to Martin. You guys can shoot me a question. But hopefully it's at least good for some reference stuff.
Great. Good job. Now, I'm going to ask you on the tape here to make sure, if you can, please, to send your PDF of your slides along, and I'll share that on the replay blog.
Definitely.
And with that, I'll take over control and wrap up the show here. And, there we go. And once again, this is just the, for Db2 LUW people, this is just the dashboard that DBI uses to help people manage workloads and ensure service levels. We'll be I've told that DBI will provide me with more slides in the future, but that's what we got today, and it helps people understand what's going on with Db2 LUW workloads. With that, that's the last slide I have here. Today's show was sponsored by DBI. The last question I have to share with you is the famous one: did you learn anything today? And that question is being distributed to you now. People are voting quickly. Thank you for that. And we'll get you on with your lunch. And I'll close that and share the result. And as expected, everybody learned something. So great show, Adrian. Thanks for voting, folks. Have a great weekend. And with that, I'm going to hide that poll, go back to the other screen, cue the music. Wish everybody a great weekend. Thanks again, Adrian. Look forward to seeing you at some event soon. And you all have a good one. And we'll see you next month on the Db2 Night Show. Happy Thanksgiving to all that celebrate it.
Thanks, Martin. Thanks, everybody.
Thank you. Right, bye-bye. There we go.